Alright, opener22, again, there's some things we can tell right away. We can tell the y-intercept is 0, 5. We can tell the a value is -1, meaning it will be going down. So, y-intercept there, and I know it's probably going down, but again, I don't know if it's over here or over there, where the vertex is. So I'm going to try to find out more by getting this into vertex form. So I'm going to do that by completing the square. Y equals -x squared plus 4x plus 5. And my criteria again is I need a to be 1, positive 1, and I need c to be 0. So let me take care of this c value first by subtracting 5. I generally always do that first, and then I deal with the a value second. Since a is -1, and I want it to be positive 1, I'm going to multiply both sides by -1. So now I get minus y plus 5 equals x squared minus 4x, and now I can do plus blank. I can do plus blank on the other side. So half of -4 is -2 squared is 4. So I add 4 to both sides, and I get minus y plus 9 equals x minus 2 quantity squared. So now I need to get y alone. So I'm going to subtract 9 from both sides. X minus 2 quantity squared minus 9 must equal -y. So I now multiply by, or divide by -1 if you'd like. And this becomes y equals -1 times x minus 2 squared. So I distribute it to that term, and now I distribute it to the other term, which is plus 9. So now I know my vertex is at, this is my vertex form. Let's move it here. And then my vertex is at 2, 9, and does that make sense? Let's see, positive 2, 9, that could make sense. Let's check it a different way. So if I go left 1, down 1, left 1, down 3, I end up right at my y-intercept where I expected. So that kind of confirms that that makes sense. Now where's my x-intercepts? Maybe I get lucky. Over 1, down 1, 2, 3, 4, 5. I do. So I could use my pattern to find those. So I know my x-intercepts are at -1, 0, and 5, 0. But what if we weren't so lucky? What if we wanted to find it algebraically? So at the x-intercepts, y equals 0. So 0 must equal -1 x minus 2 squared plus 9. Subtract 9 from both sides. -9 equals -1 x minus 2 squared. To get the squared quantity alone, I divide both sides by -1. So I get 9 equals x minus 2 squared. Square root both sides, I get plus and minus 3 equals x minus 2. Add 2 to both sides, and I get 2 plus and minus 3 equals x, which is the same as -1 or positive 5. Exactly what I found in the x-intercepts. So sometimes you can get lucky and find them exactly on an integer value, but you can't always count on that, and so you need to be able to use many techniques to get there. I just showed you yet another one. We had quadratic, we had using the squared quantity, and now we had using the jump pattern. So lots of tools in the tool belt help you find it the most efficient way. Again, my line of symmetry would be x equals positive 2, the x value of the vertex, and I have completed the problem.